I posted these slides on Twitter. I'm NZGB if you want to follow along on your computers. Today I'm going to talk about high performance in the critical path. And this is something that concerns me because I had this blog at funnyfoo.com, and it was kind of very slow because I kind of brew my own client-side rendering engine. It turned out not to be such a great idea because the server would serve the client-side JavaScript to render the whole thing, and it would take like 5-6 seconds to load the whole thing. So it was kind of embarrassing. So I decided to get into this whole web performance thing. And one of the first things that you should do to improve the performance of your sites is actually measure where you're at right now. And then you'll be able to figure out what kind of things you have to change in order to improve it, right? So let's try and do that. And there's a bunch of different tools that you can use to achieve this. So like I said, the first thing is measuring what's going on with your site. So you could use DevTools. And there's an audits tab in Chrome DevTools that allows you to run a performance analysis on your site and figure out what's going on. And you can also use it on other people's sites to get an idea of how they are approaching performance. It will give you a bunch of different metrics, like whether you are concatenating CSS or not, where you are minifying, gzipping, enabling keep alive, all that good stuff. So you should run it and figure out roughly where you're at. But this is really simplistic, right? You just open up Chrome DevTools, run it, and see where you're at. There are some more comprehensive tools that you can use to achieve better results than this one. One of them is PageSpeed Insights. You can access it through the URL, and it'll allow you to just enter your site's URL, and it'll run an analysis on your site, and it'll give you different scores for desktop and mobile versions of your site. And in this case, you'll also get a few more advanced techniques that you could or should use on your site to improve performance. And the nice thing is that you also get some tips on UX as well, because UX and performance are really related closely. So for instance, if your buttons are too small, it'll tell you on mobile that you should make your top targets bigger. Another similar tool is Web Page Test. This one is much more comprehensive than PageSpeed. You just enter the URL again and figure out where you're at. The one difference is that it puts you on a queue, and you have to wait till that queue clears up before your test actually runs, instead of just running immediately. And that's because the tests are pretty heavy in that they even record video of your site as it's loading, so it has a lot of overhead, and it can take a while, but it's worth it. And what you get back is different ratings on different parts of the performance of your site, like how long it takes to the first byte of the connection, where you're compressing your assets or not, where you're caching them, where you have CDN enabled, where you have keep alive in your HTTP requests, and whether you're caching static content. So it's something that that you should really use. And the other nice thing is that it gives you two different views on how it works. So first, you get the load time on the first visit to the site, and then you get a repeat view, which is basically when the cache is primed, how well is the site going to perform? Because most of the content should be cached during that second visit, right, if we are doing things right. And if these values are very similar, it means that we are not leveraging caching correctly, and we should improve on that. And you also get timings to the different pieces of the connection, like first byte, start render, speed index, which is something we'll see later. And there's different views into this data as well. We mentioned the different scores that we have, as well as the overall page speed score that you had on the other tool. Both are hosted by Google. Web page tests you can actually host yourself if you want to have finer grained control over it. And so there's also the waterfall view. And this view is pretty cool because it makes it really easy to figure out where your connection is blocking every other resource. So in this example, for instance, you'll notice that obviously the HTML is blocking everything, and then the CSS is blocking, and then we find some fonts on the CSS, and we have to load this as well. So during this talk, I'll try to explain to you how some of these resources could be loaded asynchronously, as to basically remove chunks of this waterfall and make the page load hundreds of milliseconds faster, hopefully. So just like we had the grades in general, we also have the grades segregated by each request. And this is kind of useful, mostly because usually when you're failing at caching and stuff like that, it's usually because of third-party scripts like analytics or ads and stuff like that. So if that's the case, you shouldn't worry about that too much. But if it's not, maybe you should look into it in the places you can control. And in the places you can't, well, you might want to consider cutting down on ads or stuff like that, or deferring them at least so that they load later, and you can prioritize the content that way. Another cool view that you have in web page test is the Filmstrip View. This one shows you the video that I mentioned earlier, and as you can see, you get a nice, quick feedback of how fast your page loads, and you get a percentage. That means how much of the page is visually loaded at that point in time. And it just displays like the interesting points, like when something first appears and when it changes. So with this, you can really easily spot issues like flashes of invisible text. And this can happen when you are loading custom fonts synchronously. So the way you fix that, as we will explore later on, is you just load it asynchronously and use website fonts meanwhile as it loads. And the other thing that it shows, like speed index is basically the visual progress of your page. It's kind of harder to explain, but the general idea is that it's a value that's explaining to you how fast your page loads, and the smaller it is, the better. Some people recommend a speed index lower than 1,000 or so, but to give you a rough idea of what a good value is for your site. So, in summary, web page test inspects every request in very detailed level, down to the TCP traffic and the handshakes in the connection and whatnot. It helps you to really easily identify bottlenecks, and it helps you visualize progress really easily. The problem with this is that if I just stop the talk right now and you guys go home or go on watching some other talks, you'll probably just run these tools once on your site, figure out, okay, here's what I'm doing wrong, maybe you'll fix a couple of them. But in a couple of months, those issues will start creeping back again up, and you'll be exactly where you left off. So my suggestion to you is that you automate these things, you measure early and often, you incorporate them into your build processes, and that way you can run them as you're pushing each set of commits to your repos and whatnot. So there's a few different ways that you can automate all of this. One of them is called PSI. It's an NPM module. It also comes with a gold package and a CLI grunt package, whatever. It's basically the same thing as page speed, but it runs on the command line or whatever else you need it. You get basically the same data, and with the API you can actually interact with it and compute things. And it might be nice using this to diff against the older builds and whatnot and get a history of how your performance changes across commits and the lifetime of your application. A very similar tool is Web Page Test API. This is basically the same, but it's a CLI against web page tests instead of page speed. You use it to get you get some results back that tell you where you are on the queue, and you have to pull this endpoint that it gives you back once and again until the results are actually there. So you can easily wrap this around with your own code and have that do it for you. But they don't make any assumptions on how you'll use it, so it's cool that it's decoupled that way. There's also Wislow. I didn't mention this one earlier because it's not really, it's kind of older, so, but you could still use it. It has like a browser extension, Phantom plugin, Grunt plugin, all the things, so you can run it also wherever you want. It's basically the same thing as page speed, so, but a little more outdated. So that's great, right? Now you have all this data about your site and how it works, but the problem usually is that you don't really know what to measure or what to do with those measurements. So the right thing to do is determine a performance budget for your site and set a baseline of performance. That's called the performance budget. And when you're below that budget, you're okay. But if you go above that, if your site is taking too long to load or it has too many images, then you should fail the build. You shouldn't deploy to production, and etc. So what kinds of metrics can you use to make those decisions? There's plenty of them, obviously. You could use simple metrics like load time, time to interaction for the user, time to the first tweet that's visible or the first piece of content that you can read. The speed index, which is the average time at which the page is loaded. Quantity-based metrics like request counts, page weight, and things like that are really easy to measure. And rule-based metrics like Wislow score and whatnot. Those are also simpler ones. In my opinion, you should use probably speed index and something else that you care about, but a speed index is one of the best all-encompassing scores that you could use to measure the performance in your site, because it's usually coupled with how fast the user can actually see anything, so that works well. To measure all of this and integrate it into your builds, you could use Grunt Perf Budget. This is a tool that is written by the guy who invented the perf budget term. So basically, it has like every single option that you could use. You can measure a bunch of different stuff, and the build will fail if you don't meet the criteria. So it's really useful for these use case. And it runs on top of web page test. So what can we actually do now that we know what's wrong with our site and we know to fail the build if something is wrong beyond minifying things and concatenating them? Well, to that end, we should look at the web stack and figure out what the improvements, the possible improvements are on each step of the on the stack. So we have TCP, HTTP, HTML, CSS, fonts, images, JavaScript, and all that. So let's go in turn. So let's start with networking. Here I usually recommend this book because it's awesome. It talks about TCP, HTTP, HTTP2, and all the lower protocols, UDP, WebRTC, WebSockets, everything. So it's really cool. You should look into it. It also talks a lot about mobile networks and the intersection, like I said earlier, between UX and performance, which is really cool. And it brings you closer to this idea where users are usually on a shitty connection on the subway or the bus going home, changing antennas as they move, so their connections are pretty spotty. So it really puts in perspective what you should be, where you should be shifting your thinking towards in terms of performance. So let's talk about TCP. What can we do with TCP? Well, there's two basic improvements that you can do at this level. One of them is make sure you have the latest version of your OS. Probably you should be using Linux. But yeah, that will allow you to increase the throughput of the connection when it first starts. And what that basically means is that TCP connections basically ramp up throughput as they figure out whether the connection can match it or not. So it's good that it starts with a bigger throughput because it saves a lot of round trips that are basically wasted time. And you can also get more data through in the first connection, which is crucial to display something useful to the user. So do that. And the other thing that you could do is disabling slow start restart. And this basically is a mechanism in TCP that whenever the connection goes idle, it will go back to the starting throughput. And this means that it sucks, because with HTTP, you are usually, if you turn on keep alive, which you should, you're usually going back to the idle state the entire time the user is browsing your site. So it kind of defeats the whole purpose of keep alive, which is awesome. So disable it and you'll be awesome too. HTTP, make less requests, right? There's nothing faster than not making a request. Turn on keep alive. Again, this is super important. It basically allows you to reuse the same TCP connection to make multiple HTTP connections. And that saves you a lot of handshakes in your HTTPS handshakes, but also like DNS resolving and stuff like that. So do that. Ship all your text content, obviously. I'm sure there's not much explaining there. Add expires and inter headers, or in other words, cache your stuff. That's useful. Use a CDN if you need to. Like, you probably don't always need to have a CDN. It's not like I'm going to put a CDN in front of my blog anytime soon, but you probably want to do it for a product or an enterprise thing. So look into that. HTTPS, HTTP2, PDES. Use all these things. HTTP2 is awesome. It's coming. So look into it, figure out what's great about it, and use it. Why? It has a bunch of different features that are great. It basically improves connections by 50% performance-wise without you having to touch anything other than flipping on a switch. So there's not a lot of technologies that allow you to do that. So it's pretty cool. It has non-blocking multiplexing. That means there's only a single connection per origin, and it's used for every HTTP connection, so you don't have to do things like sharding anymore, where you needed to be able to open more sockets to a site. So you did sharding and you placed files in different places so that they could be loaded in parallel. You don't need to do that anymore. You get header compression, which basically means there's this map of headers that's saved, and as more requests go across, there's a diff going on, and if the header was already seen, then you get the key instead of the whole thing, and this saves a lot of bytes in the header of the in the frames of every HTTP request, because usually there's like cookies and stuff that are big, especially nowadays that we are using more and more requests. So that's great. And there's also proactive server push. And I kind of hinted at this when I talked about the waterfall, where you had the whole HTML and then everything else. Proactive server push basically says, as I'm sending the HTML, I can also tell you, okay, here's the HTML, but also start downloading the CSS and the JavaScript and this font immediately, and there's no need for the browser to actually start parsing the whole HTML and finding out and figuring out that it needs these files. So it's basically hints that the browser gets and is able to load stuff faster before it even knows that it needs that. So HTTP2. Look into it. HTML, render server side, please, I beg you. You can become a single page app later. There's like universal rendering, that's a thing. We'll look into that later. Defer non-critical asset loading, this basically means everything that's not content, that's not text, that's not video, that's not the what the user came to your site to see, load it asynchronously. And keep it accessible with area tags and whatnot. Accessibility is important, so look into that too. Critical CSS. This basically means if you have a website, imagine this is a site, and if you have a website that's all this and then something else, it's like a big page, and you maybe even have like CSS from other pages in your site if you have a client-side rendered app. So inlining critical CSS basically means you take the CSS on the top of the page, figure out which styles are needed for that, and you only inline that in a style tag, and you load the rest of the styles asynchronously. That gives you huge performance improvements if you can get away with it. Remove unused styles. You know, like if you're using Bootstrap and libraries that are big like that, you're probably only using a couple of different classes, and that's it. So there's a lot of dead CSS. And even if you're not using Bootstrap, you might be using a legacy app that's like 5 years old, and it has all the CSS that's not used anymore because nobody deleted it because they were so afraid of breaking anything. So that's useful too. Avoid m.domains and device-specific domains. Just be responsive and avoid doing that, because it'll make your users' lives easier by not cataloging your site as mobile or desktop. It's not like that. I mean, tablets, and there's like a billion different device sizes, so don't do it. Concatenate and minify, and obviously follow a style guide seriously. It's like the best thing that you and your team can do to improve your CSS. Try to make it maintainable, and that way it'll actually be also easier to develop. So follow the style. Fonts, load them asynchronously if you have fonts. Use a fallback that's like a web safe. Prevent flashes of invisible text by doing this. And you can just use JavaScript for that. Use fewer fonts and avoid repaints. This is a thing that it's hard to implement, because it's not like you can go and tell your designer, hey, dude, we need to remove these fonts today. Like, we have 5 fonts. No. Tomorrow, starting tomorrow, we'll use 2. Yeah, that's it. No, not a thing. Your designer will probably ignore you. But in future projects, just work with your designer on performance issues and try and figure out what's best for your site and the user. Design actually loves constraints, so if you tell them that you should use fewer fonts, they may be pleased if you do it before the project begins, obviously. And cache fonts aggressively. There's no excuse to not cache fonts because they're so expensive to load that you must cache them. When it comes to images, you should minify and shrink them. By minify, I mean like run a tool like that removes meta tags and whatnot from them. But shrinking them is also very important in user-uploaded content because sometimes they'll upload an image that's way bigger than what you actually need. And by shrinking them, you'll make them much smaller in size too, so it's very useful to do. If you have many images below default, you should defer loading them. And that way the critical content will load much faster, right? So this is all about deferring the non-critical content, which is not even visible yet in the page. You could also even do like predictive loading of as the user is scrolling and they get near, you load them before they actually come into the viewport, so there's no need to do like some flashy thing that pops them out or whatever. Try inlining tiny dynamic images if you can. Things like gravatars and stuff like that, but not actual gravatars, but maybe like icons and stuff like that. It's useful to inline them with like base 64, but the problem with this is twofold. It's slow mobile, and you can cache them, and it's bad practice with HTTP2. So a lot of this stuff that I'm talking about today is actually bad practices in HTTP2 because things like concatenation don't make that much sense with HTTP2 as they do today. And use CSS for simple icons, obviously. If you can get away drawing a circle with border radius, do it. It's way cheaper. When it comes to JavaScript, you should be able to live without it. And this means you should be able to defer all of it. And because your server-side rendering the web app, the content will still be readable as the JavaScript loads on the background. And this means just that the content will be there faster for the users. Use small modules. Again, this is more on the maintainability side of things, but also useful. Use asset hashing and caching to make sure that the code doesn't get there time and again. Yeah, and that's about it for JavaScript. So how the hell do we do all of this, right? Well, let me drink some water first. This is hard. I'm not prepared for this. There we go. Okay, so first thing, look into Nginx. It's a reverse proxy that you can put in front of your front-end servers. It gives you static asset caching. It supports Speedy, which is the precursor of HTTP2, so it has a bunch of those optimizations in there. It has GZIP compression and it makes it very easy to do. It's highly performant, plays really well with Node.js, so look into it if you don't already use it. It's very easy to use. Set up a CDN. Again, look into it using one. Don't actually just go headfirst into one. If it's your first time using a CDN, probably go for Cloudflare. It basically just reads your DNS entries and replicates them, so you don't even have to do anything. You just have to point at their name servers. So it's pretty cool. If you want something more enterprise, you can use Fastly or CloudFront with the Amazon S3. But yeah, research. For shadow rendering, there's a bunch of different things. The problem is none of them are actually very good. Backbone needs render, which is a terrible library. Angular presumably will have shared rendering or universal rendering in 2.0, but right now it's kind of uncertain. Ember has some sort of preloader, but it's actually for SEO purposes at the moment, for now at least anyways. Taunus is a weird library I wrote that has universal rendering support, but nobody uses it, so neither should you. And React has native support, and it's actually pretty decent, so you should use that if you care about performance at all. So yeah. When it comes to deferring assets, scripts are pretty easy to defer. You just add the async attribute, and that's it. When it comes to deferring style sheets or fonts, you can place the link tag in a NoScript tag, and then load it with JavaScript. And here the trick to load it asynchronously is to set the media type to an invalid type, like only X, and then after a timeout it'll change to media type all, and that'll make it load asynchronously. Don't ask me why, but it works. And use CSS. You can use UnCSS for this. It's just like everything else, a command line tool, gulp, grunt, whatever. It has an API as well. You basically do UnCSS on your site, and it'll give you all the things that are well, all the things that are actually being used, so you can put that back in a style tag or a style sheet. Inlining critical CSS. This is the part that has actual value when you want to load styles asynchronously. It's pretty unusual to load styles that aren't font asynchronously if you don't do this. There's a tool called Penthouse that does this, that you can basically run on the command line with Phantom.js as a plugin. Basically what it'll do is it'll run on your page and figure out where your styles are being used to render the top half of the site. And then it'll give you out all of the styles that are being used for the critical path. And it'll be up to you to take that CSS, put it into style tag, and defer the rest of the styles. If you want something a bit higher level, where you don't have to do the inlining yourself, you could use Critical, which is a module that's also a Grunt plugin, I guess. So yeah, look into this. It's pretty cool. Google's pushing for it, or at least it was last year. Use a font loader. You could use font face unload to do this. Basically, you defer the link tag with the fonts like we saw earlier, and use this to detect when the font actually loaded. You add a CSS class onto your document, and you replace the website font that you used to load the page faster with a class that uses the custom font family. Optimize images. You can use ImageMeme for this. It's very cool. It has an API, CLI, Grunt plugin, Gulp plugin, or not. It works with JPEG, PNG, SVG. It works. And this will basically do mostly removing meta tags and whatnot, but also actually optimizing images depending on the plugins that you use. But it doesn't do all of the shrinking that I talked about earlier. For those things, you could probably use Graphics Magic. It has an Node.js API that you can use, and it's pretty easy to just say resize 900 and make it 900 like largest size for the images. Create sprite sheets. You can use Spritesmith for this. Don't make your designer build them for you. That's gross. You just give it the different images that you need, and you tell it where you want the CSS to be placed and where you want the actual image sprite sheet. And what's really cool about this is that it allows with JSON or Silus or Less or SAS or whatever you want. And it makes it really easy to integrate the icons into whatever CSS workflow you have. So it's pretty nice. You can inline images with base64 using the data URI module. Again, it has API, CLI, all the things. You just run it against a file and it gives you back the data URI. So it's pretty easy to use. Use a module system, please, I beg you. Look into Browserify or Babel. To me, these are the two best options right now. You could also use Webpack, I guess. So do that, and you'll be awesome. And people will be astonished. Another thing, all of the content of this talk is basically crammed into a workshopper thing that's self-guided that you can do on your own time, on your own computer. Just do npm install perfcool globally. It has a bunch of different exercises, and it'll walk you through each of them, and you'll be able to play around with all these things that I've been talking about today. There's also a book that I wrote that talks about a bunch of this stuff, and also about testing and REST APIs and build automation in general. So I guess it's pretty cool because I wrote it. I brought a couple copies to give away. I'm not sure how that'll go, but yeah, I think the organizers have something set up for that. And yeah, that's all I have. Thanks.